Let's look at a reminder about number sets. These are grouped together for a reason. Let's talk about what these types of numbers are. Natural numbers are what we call the counting numbers. We start with 1, 2, 3, 4. Like counting something, if you pick up something, that's one of it. Pick up another, that's 2. Pick up another, that's 3. You always start with 1 when you're counting things. The whole numbers are the same thing as the natural or the counting numbers, except that they start with the 0. So whole numbers are 0, 1, 2, 3, 4. They're only positive numbers, including 0, which isn't considered positive or negative. And they're not decimals or fractions. Integers, though, that includes negative numbers. So let's take this same idea and go, say, from -2 to -1 to 0 to 1 to 2. And it's all the numbers before 0 and all the numbers after 0, but only the whole numbers, meaning, again, no decimals or fractions. It's not until you get to rational numbers, and I'll go over here so I have more space, that's where you get numbers that are fractions or decimals. So 1/2 is considered a rational number. 0.4 is a rational number. -3.79 would be a rational number. But all these others are also rational numbers. So 4 is a rational number. 0 is a rational number. -2 is a rational number. So natural numbers are included in whole numbers. Both the natural and whole numbers are included in integers. All three of those are also included in rationals. Then the real numbers are all the numbers, decimals, fractions, including what we call irrational numbers. So this is actually included in this, because here what you get in the real numbers is all of the rational numbers plus things like irrational numbers is a decimal that never ends and never repeats, like the square root of 7. Square root of 7 is not a perfect square. And what it actually is a decimal. If we did it on a calculator, we would get, that is 2.645751311, and then it continues. This calculator I have only goes to that many spaces. And we don't say that they're equal, because the square root of 7 is this number all the way out to infinity, and it never stops and it never ends. So no matter where you stop it, you've now gotten it not exactly the same as 7. So what we do is we use this symbol, or most of the time, instead of that one, in fact, I prefer not to do it with with crossing through it, because that means it's not the same. Instead, we use this, which is approximate. So the equal sign means two things are exactly equal. The approximate sign means they're very close. So I would say that the square root of 7 is approximately 2.6, because that rounds from the 4 and goes down. Or you could say 2.65, because the 5 would make the 4 into a 5. Or we could go one farther. We could say 2.64, and then the 7 makes the 5 into a 6. Or we can keep doing other ones like that, but you have to round correctly. So this symbol is something you should be using whenever you have to round something, right? Equal sign for when they're exactly equal, and the approximate sign when they're not exactly equal. Imaginary numbers, those are the numbers that don't actually exist, but we still use them in different things. And primarily, this is square root of -1. And that actually includes all square root of negatives. So a negative number, if you think about it, you cannot get a square root of it, because what the square root means, let's go over a little bit of the meaning of imaginary, or of the square root. Square root of 16 is exactly equal to 4, and that's because 4 times 4 makes 16. Now, if I said -4 times -4, that would also be 16. The idea is that these two things have to be exactly equal, 1, 2, and they have to be exactly equal in order to square to get that. So the square root has to be something where it's two of them would make that number. There is no way to get a -1 by multiplying two things that are exactly the same. The only way you can get the negative is by multiplying a negative times a positive, and that means the two numbers would not be the same. So let's take that 16. Square root of -16 is not a possibility right now. There's things you're going to learn to do later on. We deal with it in Integrated Math 3 on how to handle that, where we will work out something. But right now, suffice it to say that you can't get 4 times 4, because that would be positive 16. -4 times -4 is -16. 4 times -4 gives you -16. Well, this would be a positive 16. I said that wrong. 4 times -4 is the -16. But that's just it. Is these are not the same. This one and this one are not exactly the same. Therefore, it can't be the square root of that. So the square root of -16 is called imaginary. And so these numbers are all real, and these ones are not real or imaginary. Like square root of 16, square root of -16. Square root of any negative anything is going to be an imaginary number. All right, now let's move on to, I'll use black and cross this out. Okay, now when subtracting integers, this is a simple thing from grade school, but it's probably the biggest place people make a mistake when they're making an error with negative. This one's relatively easy. So let's look at it. One way to think of it is 483, take away 247. Okay, so 7 from 3, can't do it, make that a 7. Carry the 1. So 7 from 13 gives me a 6. 4 from 7 gives me a 3. 2 from 4 is 2. 236. So that's our answer here. That is when you have the larger subtract the smaller. But now we have a smaller subtract a larger. Now, if we do 247, take away 483, we're not going to get something that works. So you can't do that. Instead, the simple way to do this is to reverse or ignore the fact that that's subtract there and subtract it this way. Bring that 247 to the back and do it like this one. So if we do that, then we do 483 minus 247 and we get 236. But because of the fact that that was negative right here, in fact, I will get that. Because it really was negative, and it's very obvious that if you have a positive take away a much larger negative, you're going to get a negative answer. That means you have to make that answer negative, even though the way we did it here came out positive. This kind of thing is only what we call a construct. We set it up and make it up special, do it differently than we should do it, just for the purpose of ultimately getting the right answer, which would be a negative 236. So you have to add that yourself. Add it yourself. There. So this is the thing that I want you to be aware of for that, only because people make mistakes a lot on that if you're not careful. All right, now that ends, I'll talk about the main things from section 03.